Hi, I'm Paul, and this is my garage.
So you say your motorcycle broke down. Motorcycle, motorcycle. How do you fix it? Go all around. Motorcycle, motorcycle. Push around the back and watch the balls go rush on. Motorcycle, motorcycle. Get your motorcycle back on the road. Motorcycle. Run out!
Hi, welcome to Paul's Garage. In this episode, I'll introduce you to the fuses on your motorcycle. I'll start by telling you what they're for and where to find them on your bike. Then I'll get into the problems that can arise with fuses and how to solve them. Fuses are devices that do not allow more than a certain amount of current through a wire. Here's a glass fuse, typical of older motorcycles. They're useful because if too much current flows in a circuit, the power source can be damaged or something could overheat, causing heat damage or even fire. On a motorcycle, there are three main reasons why fuses may blow. The most common is a pinched or abraded wire. This can happen easily if a wire gets pinched against something sharp on the frame, like between the gas tank and the frame, or rubs against something that moves for a while. The insulation around the wire will be cut or worn through, and the wire will touch the metal parts nearby. Whoa, the light went out. We can replace the fuse to show you the next thing. This is a lot like it happens on a late 70s motorcycle. Put in a new fuse, turn on the light again. Now here's what happens when the wire gets mashed against the frame for long enough. Wearing through the insulation. This is another thing you're likely to see, especially near one of the wheels, the rear wheel for instance. You'll see that. If you see rubbing on the insulation like that, you got more zip tie work to do. And by, the light goes out because the fuse blew. This here's a wire, and you can see the shiny wire through the insulation. And this is your smoking gun right here. If you've had fuses blowing, then this here shows you pretty much what happened, and you've got to find a way to protect that length of wire. We'll see what we find on our test bike, but it's a very common thing. The second major cause of a short is a connection that comes loose and hits the frame. This can happen if connections and repairs are not properly insulated or tied down, so they can't move around. All right, well here I've got the circuit, and we can pretend this is some part of your bike that came loose that you forgot to tighten up. Maybe it's a connector, maybe it's a switch. And imagine it just kind of swinging around and hitting stuff. Eventually it could hit the wrong thing, and out goes the light. That's the other way that fuses can blow that's pretty easy to decipher. You don't need to understand electricity for that. The third major cause of a short is a failure of an electronic device or a high-powered light. It might be an accessory like a radio, or it might be a basic part of the bike, like the regulator or rectifier, or the headlight. These lights typically don't blow fuses when they blow up, but headlights do, or they can because they're high enough powered that they can short on their way to blowing out. These sorts of things can develop shorts inside themselves when they fail, and they may blow any fuse that's between them and the battery. On a motorcycle, there are typically 3 to 5 fuses, unless you have one of the modern ones with electronic overcurrent protection. Most of them are probably near the battery. Sometimes there are 1 or 2 scattered around the bike. For instance, my KLR 650 has the fan fuse mounted right next to the fan. What goes wrong with fuses? They blow. Why? Something may have burned out, which needs to be replaced. You may have wired something wrong, and if you throw the wrong combination of switches, it may make a short. You can replace the fuse and try again to collect more information about what causes it to blow, but things won't be right until you find and correct the problem. Also, fuse holders can get corroded or dirty or loose. This makes the fuse and the fuse holder hot. The fuse box can melt. The fuse can blow even when it's not supposed to, due to overheating. And less power will get to the load, so your lights are dimmer, your sparks are weaker, etc. The battery won't charge as well either. We'll go over how to correct this when we go out to the bike. All right, now it's time to go after the fuse box. Gotta go find it. Usually it's near the battery. And usually these side covers have little rubber grommets to put them on so they can take off by hand. If they don't, they probably have a screw or two. You can use a screwdriver, no problem. I think I see the fuse panel, it's under here. Now I need to go after that with a screwdriver. Looks like it's attached in one more spot. Let's see what it is. Oh, that's clever. It looks like they just made it to bend down. Well, here's a whole lot of good stuff. Got a bunch of fuses. Here's a fuse box right here, and here's a couple more fuses. And it looks like there was one fuse that someone installed since the factory. Looks like they did a pretty good job. They probably soldered the wires, which is not bad. It's not the very best or the easiest to get right, but if you get it right, it's fine. And they heat shrunk the tubing over top of it. That'll do good, but we've got to look and see what the condition is of all these things. Make sure the metal's shiny, make sure it's clean, and hopefully cover it with dielectric grease to keep it that way. So, I'm prying off the top of the fuse box. Oh, looks like this one's made to sort of come out. This one mounted by a little rubber, a little metal stick that sticks through the rubber and you can pull it off. Look at that. Wasn't that nice of them? They made it so it'll all pop out. I find Kawasaki engineers to be particularly thoughtful. All right. Here's our main fuse box. You got 3 fuses here in the main fuse box, and on the back of the box it says white, main, 20 amps, and then the white red. The white and the white red refer to the color of the wires that go into that fuse. Now I couldn't tell right away if it was to read this way and then this way, that the white was the right hand one, or was it the white the left hand one. But get this, it says what color the wire is, and look at this. Here's a white wire, or at least it was once, and it goes to this fuse. And here's a white and red wire. So what? And look at this, a missing fuse. Sherlock Holmes trick here. Look at that, the plastic that's holding the fuse holders in place on this one, and up here too, is all melted. The other ones don't look the same. So we've got a little detective story here. There was a time when this fuse, this main fuse, which does typically carry most of the current, but more current than any of the other ones, it had so much heat in it that it actually melted the plastic that held it together, and the user had to solder this other fuse holder in to replace it. Now, why does that happen? The reason that happens is because of corrosion, because of a bad connection. This fuse is starting to have it happen to it. You notice how this fuse on the left has a really nice shiny metal contact between the fuse and the fuse holder. Look at that nice gold color. Well, this should be gold or brass color too, but it's all brown. It's dull. So already you're getting corrosion, and what corrosion does is it increases the electrical resistance of the connection. If you increase the electrical resistance of a connection, if that connection is powering something that's down the line, then what you're doing is you're sucking up power at the connection. Bad connections, resistive connections that have corrosion or that are loose, they suck up power. And what they do with the power is they turn it into heat. So if this happens excessively, you end up with this melting phenomenon. And if you'll notice, yeah, even the insulation on this red and white wire was a bit burned at some point in its history. It's harder now, it's shrunken. There's a little bit of charring right near the end of the heat shrink. So this is what happens if you don't do what I'm about to do. Now what I see here is one fuse looks really good. The other fuse looks like it needs to be cleaned up. Well, I'm going to, well, hey, it doesn't cost much. I'm going to show you my fuse extractor. It's a little safer to use than a screwdriver because these fuses are made of glass. Not all fuses are made of glass, but these ones are. Here we've got a fuse puller. Some of them look a little different, some of them are hooked. This one's got a really clever twist-on feature. So I'm going to use it to pull out the good fuse. Looks like the fuse comes out about as easy as the fuse holder. Now these connections are good, but it looks like it's not been greased, so I'm going to get out the dielectric grease. Got here that silicone dielectric compound. The reason it's better than Vaseline, which also works for the most part, is because it doesn't absorb any water at all, which is better corrosion protection. So I'm just taking it in my screwdriver and I'm coating the inside of the terminal with it. Then you go after the fuse. And then you stick it back in. First I put the holders where they belong. There. So I've just protected that connection. It was in fairly good shape to begin with, but I protected it. Trying to move the connectors together just a little bit.
Hello, here we are today on a somewhat beautiful day. It's gorgeous outside but a little chilly here at Betty's Bikes and Buns. What do you like best about your motorcycle?
Well, it's just the freedom of being out on the road and the absolute concentration it takes when you're riding. To be safe and ride a motorcycle, especially around a city, it requires that 100% concentration, and so you forget about everything else that's going on in your world when you're riding a motorcycle.
Well, on this one it handles good, and yet it's got quite a bit of power, so it'll run the freeways, run out on the highways real nice. I do have another motorcycle. It's a smaller one, a Ducati, but that's pretty old. It's a classic.
What do you like best about your motorcycle?
I can handle it. I can stand up on it, and
It's always a feat
the weight
for
and
the female.
yeah, to be able to control the bike for my size and what my needs are.
Well, I like Italian bikes in particular. So usually it's the sound of them and how they handle in corners rather than strictly how much power they have for a straightaway.
Everything.
Everything.
This is a bike that was a limited edition. The last year that it was made was 1996, and this is a bike that I've wanted to buy since I was probably about 21. So it was a long time waiting to get a BMW, and it was worth the wait. It's an incredible machine, very reliable. Been all over the western part of the United States with it, and up at 15,000 feet in altitude, no problems. It just keeps going. Every year I go to the motorcycle show, I look at all the new bikes, and when I leave, I'm glad I have what I have. I wouldn't
Very
trade it for
cool.
anything.